Let's see. Good evening, everybody.
Hey, good evening.
Thanks for coming out on such a beautiful night like this. Let's see. In attendance tonight for the task force, we have Clarence Casper, Bray Rafferty, Michael Noel, Frank Boland, and Michael Flynn.
Mike Flynn's here.
Yep, Mike Flynn's here. Town staff, we have Town Manager John Burt and myself, Director of Public Works, Greg Hanover, and from AECom, our consultant, we have Jonathan Ives. This is meeting number 6. I did send out an agenda. We're going to kind of review where we've left off a couple months ago, and then go over the profile and the plans and the impacts to the property, which I think, I've looked at with John Ives, and I think, they look pretty reasonable from an engineering point of view. And they'll also talk about a little bit about the some of the bridge design, what the bridge might look like. So, John, I'll turn it over to you, I guess.
Very good. Let's see. Okay. Well, I apologize for not getting the information out earlier. It was a bit of a scramble for us, but here we go. So as Greg mentioned, we're going to kind of go over how we got here, just reviewing quickly the goals and the controls. And then we'll look at the profile, the plan, the property impacts, talk a little bit about the bridge design, then open discussion and next steps. Going back to the beginning, our basic goals that we established were to address the condition of the existing bridge, to improve or provide resilience, to improve the vertical clearance at the bridge, and to provide bicycle and pet accommodations. As far as the bridge condition goes, that is addressed by we're providing a complete replacement. We talked a lot about resilience, and just to rehash some of the basics, the low point on the roadway now is elevation 7.8. The 50-year flood event elevation is 7.6, and the 100-year is about 2 feet above that. We noted that trying to increase the elevation of the causeway has substantial right-of-way impacts, and so we settled on a target of being at elevation 8.6, which is 1 year above the 50-year event. And we also aim to improve resilience by armoring the causeway with heavy riprap along the banks to prevent washouts.
Jonathan, you said 1 year above.
1 foot above the 50-year event. Sorry if I misspoke. Since we have the information, Frank, I believe I mentioned that we got the hydrology report in from our sub-consultant. And I just want to show one quick graphic from that. This is flood elevation approximated based on a historic storm event. So this is for, here's the historic event, which is from 1938. That's the date of the event. And then this graph here is showing water elevation with time. And what you're seeing here, if you picture the flood elevation, we're talking about having a causeway with a minimum elevation of 8.6, which is here on the graph. And if you look at the top of this chart here, you can see that, this is hours. They call it hours from midnight, but this is just hours. So on the bottom here, if you correlate that to the time that the water would be above elevation 8.6, I guess what I'm trying to say is it's a very brief time. We're talking about an hour. So, and that's for the 100-year event. Our next goal was to improve the vertical clearance at the bridge. Control for that was obviously right-of-way impact. Because the bridge, there is some distance between the bridge and the adjacent properties. We were able to pick up the low chord, which is like the bottom of the steel on the bridge, substantially. You'll see later on in the presentation, the proposed profile does provide a foot of underclearance for the 50-year event, which is a gain of 3 feet above the low chord of the existing bridge. So the bottom of steel on the existing bridge is at about elevation 5.6. And with our proposed design, we're going up to 8.6.
Sorry,
Frank, you're
sorry,
muted.
Jonathan. We probably should save our questions for later, but you lost me. You had I thought you had a roadway elevation of 8.6. Roadway, blacktop.
Here, I'll go quickly to the profile. Our low point is away from the bridge. Actually, our low point is about where's our existing low point is in front of 981 Groton Long Point Road. And that's about 7.6 at the edge of road.
Mhm. I see.
And looking at the profile, that's back here. The bridge is, several hundred feet away from that. Oh no, it's a couple hundred feet away from that. But we're making an adjustment. What you see here on the bottom is this dashed line is existing grade, and up here is proposed grade. So we're not picking up the whole causeway, but we're picking up the bridge and sloping up to that from either approach, such that at the bridge, the bottom of the new bridge is at elevation 8.6 versus the bottom of the existing bridge, which is at 5.6.
Thank you. Clear.
And the last goal here was bicycle and pet accommodations. Again, controls were right-of-way impacts because there's no sidewalk there now, and we are widening the roadway slightly to provide bike lanes, and we are adding a sidewalk along the south edge of road. So I guess the right-of-way impact affected which side of the road that we chose for the sidewalk, and that's what led us to put the sidewalk along the south edge of road. So just to get back into the profile. Project goes from East Shore Ave, where we're matching grade. I know this is going to be difficult to see. And I have emailed everyone this figure as an attachment. And we're also matching in at the east end of the project in the vicinity of the restaurant and the beach. And we discussed how much we're picking up the bottom of the bridge, which is about 3 feet. Because we have a longer span, we're going up to an 86-foot clear span in order to bridge over the existing substructures and build behind them, as well as to open up the waterway. We need a deeper structure, and so we're picking up profile grade by about 4 feet at the bridge in order to get that 3 foot additional underclearance at the bridge. Sorry about the cat. Does anyone have any other questions about the profile?
No.
I guess one other thing I'll mention is we were able to move the low point away from the bridge to a location where there is existing, where there are existing drainage structures as well as a drainage right of way. So there's a drainage right of way down this driveway here, which would be convenient for design to be able to utilize that. All right. Now on to the roadway plan. This figure was also emailed out to the group. What is shown on here in brief are, the project limits are basically shown on this sheet. In red, you will see the right-of-way lines. These dark lines that have an F and a C in them are cut and fill lines. And those basically represent the extent of regrading beside the road. So where you see an F, that's a fill line. And where you see a C, that is a cut line. So along the north edge of road, we are filling a little bit on these properties. At the line, that's the limit of the fill. So there would be, basically that's where the fill starts. There's 0 fill at the line, and it increases in depth as you go toward the roadway. The same would apply to a cut line. For example, at 1000 Groton Long Point Road, along this line, there is no cut or fill, but that's the cut line. We are cutting, inches, a few inches down at the edge of road. So the elevation of the driveway here is dropping a little bit. And you would think that there wouldn't be any cut because we're increasing the elevation of the causeway, but the roadway is not a uniform in its slope. So it happens here that we end up with an odd little bit of cut at this location. But generally we are in fill. And the grades for the driveways have been limited to a maximum of 15%. And wherever we are filling in someone's lawn, we are at a maximum of a 6-to-1 slope, which is relatively flat and maintainable. As we get into the causeway, where we have heavy riprap, we are using a 1.5-to-1 slope. That is to, a riprap slope that is not going to be maintained other than, possibly dumping some more stone in there if any of it ever washes out. So that's something that no homeowner will ever have to maintain, which is why we're able to use that 1.5-to-1 slope. So that continues, that steep slope continues along here from station 14 up to the bridge on the south, and about from station 1525 to the bridge on the north edge of road. And similarly east of the bridge, this area here up to about station 1950 has that 1.5-to-1 riprap slope, maybe 1900. And then along the north edge of road, that steep riprap slope ends at the little bit of lawn here adjacent to the restaurant. So right-of-way impacts, I'll just use this figure, although they are in the presentation as well. You can see that we have the sidewalk along the south edge of road within the right-of-way, and that in front of these properties on the south edge of road, the cut and fill lines are all within the highway line. As we go toward the bridge, the heavy riprap does have to cross the highway line. But this is an area, again, that's already riprapped. It's just that the toe of slope moves a little bit to the south. Along the north edge of road, there are more substantial property impacts. We've been speaking mostly about 991 and 981 Groton Long Point Road. Although the cut and fill lines do extend pretty far onto the frontage of those properties, again, the slopes, we were able to maintain something reasonable for those with the 15% max for the driveway and the 6-to-1 max for the lawn areas. Greg and I were out at the site and looking at 981, which has a couple of trees in the lawn here, and we looked into that pretty closely and felt that the amount of fill at the trees was minimal, so it was not going to damage or be a threat to this tree here, and it doesn't extend to this tree. In these figures, I want to point out that at the project limits, these areas are in development. They're still being worked on. Our concept is to bring the sidewalk to the crosswalk and to terminate it there. the area in the intersection here, the extent of the paving is not finalized, but in this area, it would just be like a mill and overlay, and you would get into full depth as you go away from the intersection. At the east end of the project, our goal is to bring the sidewalk to the crosswalk here at the beach. A little bit of realignment of the road is still needed, or of our baseline is still needed here. We don't intend to realign the road, but this is something that still has to get cleaned up a bit. But the cut and fill lines are generally, they're certainly accurate through the middle of the project. Just the ends are still a bit of a work in progress. Does anyone have any questions about property impacts?
Question right where you are now, on those two houses on the north side.
Yes.
You had a picture of the actual front of the house.
981.
Yes, this is just Google, but yes.
And it just, I'm not quite understanding about how much fill, how
Sure.
how high up is the lawn going to be, let's say, in the future? You know, are you raising this thing up 3 feet? Are you raising it up a foot?
Yeah, that's a fair question. So looking here at the baseline in front of the property, which is our frame of reference when we look at the profile, you can see the driveway is at about station 1425. And then we're going to about station 1525. So we're looking at this 100-foot frontage here. So I go to the profile and I look at those same stations. Here's 1425. At the driveway, it looks like there's about a 1.5 feet, maybe. That's out at the center line of the road. And then at 1425 would be back here, about a foot. And then 1525, just a little over 2 feet. And that is in the lawn area. So let's go back to that street view. Oh, sorry about that. So we're talking about a foot at the edge of the driveway here. And that would be the height close to the road. And go back to my microstation file. Which somehow got moved around. Okay. So the limit of that fill in the driveway, fill, so to speak, is about 26 feet. So it's going to extend to about where the edge of where these cars are parked here. So the driveway will obviously get steeper than it is.
The driveway will have to be higher than the roadbed so that you don't have runoff going into
Correct.
the.
Yes.
What?
And that is the intention. There will be like a lip along the edge of the driveway and then a little bit of a hump and then it'll come up even beyond the roadway elevation. So the first few feet of the driveway will drain toward the roadway.
Right.
And John, do you have those
Only
cross
only the
sections?
only the lip of the driveway really for some distance in will be higher than the roadway, not.
Yeah, so the standard detail is usually there's a little lip right at the edge of the road.
Yeah.
Maybe an inch to an inch and a half. And then you have a little slope up toward the house so that water drains down the apron toward the roadway and not from the roadway down the driveway toward the house.
Maybe we could simplify things by, that house I think is on the market, or we could get rid of the house.
It's yes, it's a HUD property, I believe. So that might actually complicate things.
So up by the mailbox in front of that house, that's going to rise up about 2 feet.
Right. So I'm looking at this mailbox. I'd say that is about maybe the height of the post.
Right.
Very, very difficult to tell from a street view.
Yep.
Things can be very deceiving. So,
Would
but
that be a wall situation rather than a fill?
you could use a wall. It would just be a cost. There is a utility here. So that piece there would have to be flat, would have to remain flat, right?
Right.
So there would be some grading to be done there. I guess if you were to have a wall there, it would be a little complicated because of where this utility is. You wouldn't want to have a wall on the roadway side of that. I think you'd want it on the back side, on the property side. Because if you had a wall retaining the roadway here, you'd have a drop off and you would need to have guide rail on top of the wall or a taller wall, which would be worse for the property owner.
Right.
So I think the best we can do here is grading without the wall. If they wanted to have a dead flat front yard, I'm not sure the routing of this utility, but we probably could put a wall on the property side of the facility.
Thank you.
You're welcome. Any other questions about property impacts? I know that some of the figures are difficult. I'm trying to be as transparent as possible. But we'll move on. As far as the bridge goes, I know that this is the figure that was shown to the town early on, and it's still a fairly accurate representation. It doesn't show the rise in profile grade at the bridge, which again, we said was up to 4 feet. And we do think the project will extend a bit further to the east than is shown here. But as far as the limits of the walls will be about the same as what's shown here. We will use an open rail along the bridge. And we will be cutting these abutments down, so you will not see this as it's shown here, but we will have heavy riprap slopes similar to what is shown here. Here's a view of the existing bridge, and just to emphasize, we have a 50-foot clear span now. That elevation 5.6 is the bottom of the steel, and the channel bottom moves over time. Based, I've reviewed the inspection reports, and you have aggradation scour and degradation scour. So just the flow of water through here brings in sediment and deposits it, and then washes it away in kind of a cycle. So that's why you don't see a uniform channel shown on this figure. 50-foot span, 5.6. And for the proposed bridge, we're going to an 86-foot clear span. That is to build our proposed abutments behind the existing abutments. So we don't have to remove what's there in its entirety, which would be difficult. There is an opportunity locally to do some work in the channel. I know there was a question early on about dredging. It would be outside of the project to do dredging of the channel, say out in the cove or on the sound side, but we can clean things up certainly locally in this area.
Well, you're showing,
There'd be an opportunity to have, an improvement for boat passage here.
right. The channel you're showing, Jonathan, has been reconfigured. So
Yes.
you're figuring a dredge down there.
Yes, so we already have to remove the existing abutments. So we're already into the channel just for
Sure.
that purpose. And then I guess just when that work is done, some of that's going to be addressed. So 86-foot clear span, the low chord 8.6. That's the bottom of steel, which is 3 feet above the current bottom of steel. So I think that's a significant improvement.
I'm sorry, it looks like your channel depth.
The depth is a bit, we're showing it's a little bit deeper here.
It looks-
And certainly, if you go back to the previous figure, that at the time that this was drawn, this was taken from an older report, but it had showed some aggradations. They call it aggradation scour. So some sediment had built up along the western abutment. And again, this is a cycle. It's probably different now, and it would probably be different if you went out there next year and measured every year or every 2 years when the bridges are inspected. They take a measurement of depth along the front face of the abutment. And what the inspectors are looking for is how close are you to the bottom of the footing, and is there any place where the bridge is undermined or in danger of being undermined? They're also looking at how this channel bottom moves from inspection to inspection, which again is on a 2-year cycle. So we do have pretty good information on what the channel looks like along the edges of the abutments. And, you know, at this point, everything in between is kind of an educated guess. We don't have bathymetric survey of the channel now. Again, I don't think it's really needed for this project.
The only reason I ask a question is that what you normally have for the channel through a confined flow like the bridge
Yeah,
is an equilibrium between what the sediment is and how it moves around and the flow that's going through there. So you establish something of a stable channel configuration. When you on the new drawing, this water depths look to be about 5 feet, maybe 5-6 feet here, if I'm reading this right. But on the drawing you just showed me, the new one, that guy, depth is, first of all, the configuration is nicely symmetrical, which it won't be because historically, you know that the flows favor some asymmetry.
well, right. It would eventually become some different arrangement. Initially, you know, we would have some riprap in here, and that would likely fill in with sediment, and the shape would change over time.
Yeah, well, we looked at a lot of these guys, and there's design and reality. But I'm thinking that you're going to dredge to something like closer to 10 feet on that drawing. The bottom looks to be about, yeah, running across.
Yeah, I'm not.
I don't know. It doesn't make any sense to put a square on this thing, I guess.
I'm not sure it should be that deep. I believe the bottom of, yeah, there may be an error there, Frank.
Yeah.
I believe the bottom of the existing is about negative. -8. Oh, sorry, I'm in the wrong. But I think you're correct. I think that's too deep.
Yeah, that guy there, I'd say 5'6", something like that. Maybe.
I have it in my mind that the bottom of the existing channel is about -8, and what
Okay.
we intended to show was like -9.
Right.
But a small difference, not a large difference in depth. So
But when you're going to have an 86-foot span, which you don't have now, and
Right.
so the mean velocities are going to be lower, and
Yes.
so your tendency to get a little bit shallower, probably some accumulation, possibly.
yeah, water does move pretty good through there now.
Yep.
And here's the staging. You may have seen something similar if you looked at our past reports. What is notable on here is now we're showing the difference in elevation between existing and proposed. The steel girders are about 3 feet deep. And so you can see that's also about the difference in elevation between the bottom of existing steel and the bottom of proposed steel. We are showing a steel bridge. We have done a design on that just to get a depth and know that we were going to be accurate when we did our work on the profile, and that we would be able to tell you with certainty how much of an increase in clearance you would be getting, and to know that we had the right target for the profile over the bridge. The staging right now is showing a temporary pedestrian bridge. That is something that certainly is up for a discussion with the town as far as whether that is desired during construction. So in the first stage, we have alternating one-way traffic on the existing bridge while we demolish half of the existing bridge. We have about 13 feet to work with here, which is like an 11-foot lane and 1-foot shoulders. So it's not a good accommodation for pedestrians, but if we were to accommodate pedestrians on the existing bridge during construction, we would be talking about a substantial widening with a proposed condition, which we don't want to do. As we go to stage 2, we'll be maintaining alternating one-lane traffic on the proposed bridge while the remainder of existing is demolished. But here in stage 2, we've added the sidewalk on the proposed bridge, so there is a place for pedestrians to have safe passage. And again, on the proposed bridge, as we've discussed, once this is completed, we'll have 11-foot lanes, 5-foot bike lanes, and the 5-foot 6-inch sidewalk. The water main that's carried along the north fascia of the existing bridge will be somewhere beneath the proposed bridge. Now we're showing it on the first stage of bridge construction so that the water main can be maintained. For the railing, I just wanted to give you an example. This is James Street over the Silvermine River in Norwalk, which is a recent AECOM project. This is an open steel bridge rail. I'll zoom in a little bit further. So this is a crash tested bridge rail. It's a little bit more substantial than what was shown in the early renderings. The railing that was shown in the early renderings doesn't meet the current crash test standards, which have changed since that rendering was developed. But it's an open rail. There's pickets on the backside, which is necessary when you have pedestrians. You can't have anything greater than a 4-inch opening. And I would anticipate similar end blocks where you could either have form liner, or in this case, it's a stone veneer, which is very durable. Here's a closer view of that railing from the outside of the bridge. And you can see the pickets here and the stone veneer on the end blocks. And we showed in the early renderings lighting along the causeway, and that is still in play. It's just we have not, we're in an early stage in design. We have not looked at lighting through here yet, or what the spacing of the light posts would be along the causeway. Just thought this was kind of an apt sample or example.
That looks real nice. Yeah.
Thanks. In this case, the color is green, but the color can be whatever you like, whatever everyone agrees on, I should say.
When you remove the abutments, are you going to pour cement for the new ones? Is that like the last picture?
Let's see here.
You can see that cement wall under the bridge.
Yeah, so in this case, this was actually a superstructure replacement. So this project used the existing abutments with the tops of them were just modified to accept the new superstructure.
Oh, okay.
In our case, we'll be demolishing the existing abutments and building behind them. And there'll be a reinforced concrete structure. I can go into that just a little bit. What we're proposing is called an integral abutment structure. And what that means is the steel girders run right into the abutments. They don't sit on a bearing here. The concrete deck is integral with the abutment. It continues down. It's a very resilient structure. You know, in the 100-year flood, we would be under pressure flow by, I think, about a foot. So picture water being up above the low steel, and then you have wave action potentially on top of that. But this is a structure type that would be very adept at handling the loads that would be caused by that. So, and also it has no bearings that would need to be maintained or adjusted. It is a typical problem area for bridges is the ends of the steel girders. When there's a joint there, water eventually gets in and salt and just rots out the steel. So we would be proposing, although we are proposing steel, we would be proposing metallized and painted steel. So metallizing is a hot thermal spray of aluminum and zinc that provides corrosion protection. And on top of that would go a paint system that would be compatible with that. So it's kind of a double protection. And I think steel is appropriate here because you have the marina, and you know that even though we're providing an increased vertical clearance, they're just going to get bigger boats and the steel is going to get hit, and steel is very resilient and repairable. Whereas if we had concrete with internal pre-stressing strands, once those are damaged, they're very difficult to repair. So that's kind of some of the thought process that's gone into the layout of the structure. Any other questions or discussion items?
Oh, yeah. I think I'm clear on, can we take a look at the proposed bridge elevation?
Sure. Would you like to look at the profile or the picture of the...
I'm looking at it from the side, the elevation.
Oh, sure. Yeah.
And I had a question in my mind about the, maybe back to with the whole roadway, one of the first slides you had. I had a question in my mind about why the hump at the bridge. That's it there. Yeah, that's it. Shrink me down.
Right. So this is,
but I guess
keep in mind, this is an engineering drawing where the vertical scale is exaggerated 10 times.
Understand.
So
I guess in my mind's eye, of course, I would have the roadway as we're coming down 215 short of the fishermen.
Yep.
I would be coming up a little bit and I have sort of a smooth roadway running down to the Groton Long Point Road, the main road there, whatever the name is there. And the problem with that is that it really brings the road up quite a bit relative to the property owners on the east side there, or west side there, I guess, right? And because from a flood standpoint, it's the low point that's going to flood anyway, so why raise the bridge up? I guess the advantage of raising the bridge up, of course, is to give a little bit more clear span under the bridge, a little bit, like 3 feet more. And it's, it also puts the bridge a little bit higher relative to uh, the highest water levels, 100-year flood level, plus sea level, of course, another foot and a half or so, and the wave attack. So is that all? Am I right on all of that sort of thing? It's just,
Those are all, yeah, those are all advantages to having the bridge picked up. The feds typically do prefer the structures to clear the 50-year flood, to be above the 50-year flood.
right,
If they can't pass, technically they want the bridge to clear the 100-year flood. We decided that that just wasn't reasonable in this case,
right.
that the property impacts would be far too great. And I know that, we're not picking up the low point a great amount. It's,
Only a foot or so, I guess.
yeah, a little less than a foot. It does give you, a lot more of the road that's dry, and with a complete replacement structure, it's difficult to justify not to the feds not picking it up to clear the flood.
Yeah,
We're anticipating that we're justifying not picking it up enough to clear the 100 based on property impacts. So
right,
it's
right.
kind of a compromise.
Of course, the 100 years, in the 100-year flood event, those properties are gonna be pretty wet too.
Right.
Then I thought I heard you ask me a question. It sounded like, should we have a pedestrian way during phase 1 construction? Or did you say you were going to have a pedestrian way during phase 1
Let's go
construction?
back to the staging.
This guy, second slot down there.
This figure is showing a temporary pedestrian bridge in order to maintain or provide a safe
Yep.
passage of pedestrians while there's alternating one-way traffic on what will be a fairly narrow
Absolutely.
piece of the existing bridge.
So that absolutely, if you were asking me, I would say absolutely have it. That's not a question.
Yeah. Yep.
We're talking about a year. Typically stage construction is a 2-year process.
Right.
A year for stage 1. You have a lot of sheeting and removal of the existing structure and constructing proposed. So it might take you 1 year to get to here, where you have alternating one-way traffic on the proposed structure and you have your sidewalk. So yeah, maybe it's 5 or 6 months where if you don't have this ped bridge, you have you're not going out of your way to provide safe pedestrian passage.
Right. And the last item that I have from my notes from a couple of meetings ago, Mr. Hanover may care to address this. There was some question about property rights. I thought that came up during the discussion of the sidewalk. And has all of that been resolved? Everybody's happy? The Groton Long Point Association is happy with all of this?
No, no, that's not been resolved yet, Frank.
Okay.
But we're still within the right of way, so
Yes,
it's likely we'll be able to keep the sidewalk where we have it proposed now, right? I would think.
that's what the town believes, yes.
Yeah, okay, that's good.
Yeah.
Yeah, it's definitely a benefit to everybody to have all that extra viewing space.
When do you start construction?
Also a good question. So the federal local bridge program process is a process. We're getting a jump on it by doing some preliminary design to go along with the application to get the funding from them. You know, the reason why you go through this process is that they provide an 80% share, which is substantial. Getting into the federal local bridge program then means that there is state oversight and liaison engineer oversight. And it is typically at least a 2.5-year process to a 3-year process. So we're here in 2021 and we're showing starting construction in 2024. And that's just a realistic, typical time frame for going through the federal local bridge program. There are numerous design submissions, numerous reviews. There are permits and permit reviews, permit agency reviews. And it takes some time. So there are two programs. There's also a state local bridge program that does not have such an arduous process, but the funding is only 50%. So you know, on a project like this that has a substantial price tag, you know, most towns would go for the federal funding. The good news is the bridge that's out there now doesn't have any kind of load rating problem, although the condition evaluation is not good. It is safe from a load carrying perspective. Where you don't have safety is with the, you know, you don't have good guide rail attachments, and you know, obviously you have the outdated guide rail along the causeway, and it's not connected to the parapets. You know, but
It's 1935 or so.
1935, yep.
You know,
Yeah, when you look at the causeway here, you can see right in Google that it basically just drops off right outside the roadway. So there's nothing much backing the guide rail, which is why the width of the riprap slopes that we're showing in that roadway plan is so wide.
You showed the railings, proposed railings for the bridge, the green railings. What
Yeah,
happens out here along the road?
that's a good question. Let me go back into presentation. Let's go back and look at the rendering. So this rendering was showing a box beam guide rail tying into the end block. The end block is connected to the metal bridge rail. So it's a continuous system that goes all along the road. What you have on the bridge, you have that heavy metal bridge rail, which has, you know, almost no deflection when it's hit. Along the causeway, you have a guide rail which has a deflection to it. You know, what's not probably not accurately represented here is that there is a shelf, a flat shelf on the outside of this guide rail. So when the guide rail deflects away from the road, there's protection there. So the guide rail is a more flexible system, but it is connected to the bridge. The guide rail has to end somewhere. So the guide rail ends where the slope beyond the edge of the road or the edge of the sidewalk is considered to be recoverable, meaning that a vehicle could go onto the slope and still be able to stop or get back into the roadway. So when you get to a really shallow slope, then you don't need the guide rail anymore. So this, this box beam guide rail is one option. What's typically used is your kind of they call it W beam guide rail, which would be kind of guide rail that you'd see along the highway, but you also normally see along local roads where there's newer construction. Obviously, we don't use the wood posts and cable anymore like you have here.
Thank you.
Sure. The guide rail limits would be about the same because you have guide rail all through where we're really picking up the profile and where we have a steep slope. So it'd still end in about the same spot here, as well as over here and on the east end of the project too. Just be a different style guide rail. Any other questions?
Yeah,
Very-
would the utility lines be carried, not above like that, but carried in?
The utility lines could be buried.
Yeah.
Or they could be overhead again, as they are now.
Who's in charge of that? Is that Public Works, Greg?
As far as the utility lines, whether they get buried or not, I think it's, we'll have to look at the cost of that,
Sure.
and weigh that against, the aesthetics and, obviously it takes them away from storm surge, so they're more likely to survive. But yeah, that was one of the things that, we talked about, I think in our last meeting was, burying those lines, which, if it's not too expensive, it would be well worth doing.
And when you talk about burying, it'd be a conduit, would it?
Yeah, just a conduit with some manholes,
Right.
probably in the roadway somewhere.
Oh, in the roadway, yeah.
Yeah.
But within
Which,
the roadway, typically you have a conduit, as Greg said, and then it goes in a concrete encasement that protects the conduit.
Yeah.
Right.
And because, we're raising the causeway up so much, it's really, you kind of put it in as you're filling kind of thing. So it may not be that expensive.
Yeah. And one thing, when you talk about utilities that came to mind, are there any arguments about the placement north-south of that water line you have in there? Is one side a little safer than the other side, or is there a location issue?
Well, it's on the north side now, probably to protect it from wave
Yep.
action.
Right.
But they're showing it in between the steel girders hung underneath the bridge now.
Yeah, not quite to the south side, but it's, I
I
noticed
think
they did move down.
Yeah, that was just, I think, for phasing to keep the water from
Right.
being shut off completely for a while.
Right.
Right.
So the phasing was arranged to get the sidewalk built early. Which is why there was a shift in the location of the water main. But also so that the existing water main could be maintained on the existing structure while the first stage of the new bridge is built. If you were to flip-flop and go to that drawing,
Yeah.
and try to have the water main on the same side, you would have to find a way to temporarily support this existing water main while you construct the new bridge over it.
Sounds familiar. Didn't you do that in Noack?
Yeah, that's what they did at Mosier Avenue.
You're in Mosier, right?
They had to put a temporary in.
That could also be done. So although we're showing it built in this first stage of construction, if that's problematic because of the routing of the water main in relation to other underground facilities, and they want to keep things on the north edge of road, the water main could also be, you could be supported under the bed bridge if you have a bed bridge there. You could have a temporary one here and just have a lesser shift in location. And then say construct it in the northernmost bay of the proposed bridge, where it would also be close to the current location. Anything else?
Sure.
Okay, let's talk about what's left to be done then. So we started putting together our plans that you've seen to show the impacts. We have to do a construction cost estimate that will be part of the federal local bridge program application. We have begun our hydraulic reports. We submitted the hydrology report. We needed to have the profile done to do the and be solid on our layout to do the hydraulic report, because we need the new opening and then the shape of the causeway. So with that done, now we can move ahead with finishing the hydraulic reports and move ahead with putting together a funding application for the town to and finish our final reports and preliminary design plans, which is our current scope of work. And then I'll go toward getting you those federal dollars for construction. So let's talk about what I mentioned. We have some things to firm up on the plans at the project limits, but I think now we've shown you where we intend to go with the project. If we have a meeting in July, what would we like to see at that meeting? Or do you want to have a meeting in July?
Well, when do you think, Jonathan, you'd have like the construction cost estimates and plans kind of further along, or at least the cost estimate?
We can move ahead with a cost estimate now. We could do that for July. That could be an action item.
And in it, you might consider that business of, burial of the utilities, et cetera, that sort of thing. I'm just making some notes here, and one thing that comes to mind. It was not clear, and this is not a question, it's a statement. It's not clear where sea level rise comes in some of the calculations. If I would think that in the federal review, it ought to be very clear that you have considered a 1.5 foot or whatever it is. It depends on your time frame, the life of the project, in your designs. Not the 100-year storm from 1938. It's a 100-year storm, 1938 plus a 1.5 foot.
Yeah, I understand the concern. The current policy by the reviewers at DOT is that they use the current FEMA still water elevations as their base flood elevations. And we did speak along the way about the trade-offs between the elevation of the causeway and the right-of-way impacts and cost. And you know where we're at now with the causeway. I'll go back here.
Hmm. Hmm.
We know that the low point is in front of this house now, and that
A little further, it's a little further west, isn't it?
it's about where the
Driveway.
probably about where the catch basin is, right?
Okay.
And what we're doing is we're picking up the profile all along the causeway, but you know, especially at the bridge. And because we're picking up the profile at the bridge, you noted that there is an impact, especially on this property, as far as the grading. We've moved the low point back here to this drainage structure. There's an outlet in Palmer Cove, right on the other side of the car down there. And if we were to continue to pick up the profile, the impacts that you see at this house here, which is actually has a substantial setback from the road, especially compared to the properties on the south edge of road. I just think that the impact will be too great. We're already at a kind of a maximum grade for the driveways. And there's not much we can do.
Uh-huh.
And I think that's kind of the understanding that DOT has as far as incorporation of the sea level rise.
I think you're being kind to DOT.
They may not
The
fully buy in or believe
I understand. I think I understand very clearly what the impacts right and left of the roadway are, and that's a difficult issue for us to address.
right.
When we're trying to increase resilience, both to the long-term effects, that's the sea level rise, and the potential for more intense storms,
Right.
as they affect the access to Mumford Cove. Groton Long Point's going to be underwater anyway, and most of the roadways we're not going to be able to drive out there with ambulance. But but Mumford Cove's a different story.
Well, think about it this way too. You're putting a lot of money into the bridge.
Oh my God.
At the bridge, you're picking things up. If at some future date, whatever that date is, say it's 50 years down the road, and we've experienced the sea level rise, and say some of these buildings are starting to be, underwater or in worse danger of flooding, and you could pick up the causeway to the west, toward Mumford Cove.
You mean the
And-
roadway? Yeah,
And still
roadway.
leave the bridge where it is and still be okay.
Sure. No.
If we were flat now and building on the existing grade, that I would agree would be short-sighted. But this does have some future proofing in it.
No, I understand. It's just, we're doing the best we can with what we have.
Yeah.
One question I have, that's regarding when you're looking at the costs, since it hasn't been resolved about the sidewalk yet on the western side, about, I guess, who owns the property under the sidewalk, or how that's going to go. Would you put up two estimates, one with the sidewalk going all the way over to East Shore Road versus just going to the bridge and leaving the western part of it as we see it today?
I think that I'll discuss with Greg offline.
Right, fine.
Yep.
Yeah, I'd love to see the sidewalk go in. But I don't know how long and protracted the argument about who owns the ground underneath it is going to go on.
Is there even a question about that? I thought we were within the right of way.
Again, the town believes it's town right away, but Groton Long Point doesn't agree with us at this point. But it's public right away.
Yeah. Yeah.
Okay, anything else?
Greg, I guess that the question is that going to be resolved? And
I would hope so. I think, you know, we're trying to get that resolved.
yeah, would seem to me that there's a fair amount of cost differential in some of this, and it would affect how the package that's going up to the feds.
Yeah, because we have to nail that
Maybe
down.
it
And get,
should it be priced for the whole thing? You know, the complete sidewalk all the way to East Shore? And that way, you know, we have a maximum price that we're submitting to the feds. We can always, you know, it's always better to ask for more, right?
Yes. Yeah, get it. You can get it now.
Right.
That's the way to go. Yes.
Right. So maybe we should price it that way for now. And
yeah, we can do that.
One thing that it seems to me would help alleviate the impact on the first house on the south side would be if the roadway could be shifted a little bit more to the north. Because even a foot would make a big difference to that house.
Okay. Let's so just to be clear, we're looking west here.
Mhm.
We have this first property on the north side of road, and we're thinking about shifting the roadway or discussing shifting the roadway to the south toward the sound,
To the
Mhm.
north,
away from this,
No, other way around.
to the north.
North.
toward them.
Further down by that first house on the left there. So where that curve is, you'd be straightening, moving it a little bit to the north, so that first house, um, I see the right of way. You don't have a lot of room to move it, but if you moved it at least to the right of way, then you give that house just a touch more breathing room, and that'll make a big difference to them, I'm sure. Because they're the ones that are going to be the most impacted by the sidewalk.
Hmm. They're not built into the right of way, are they? I can't quite tell that.
Now they're right on the edge of it. That whole house seems to be,
I see it. Yeah, okay.
yeah.
Yeah,
I mean, right now, in front of the house, the frontage has no impact beyond the highway line. This house, we're showing an impact,
yeah, 981, right.
a substantial impact as far as how far the fill slope goes onto the property.
I mean, well, it's almost like you're taking away. I mean, it's unfortunate, but you're taking away almost their parking. You know, I'm not sure they'd be able to park a car there.
I think it's hard. I have a hard time finding sympathy for that house because it should never have been built there.
Yeah, exactly.
You know?
I mean, this house has a turnaround here, but there's a garage. This is a garage.
Yeah, just because their lawn is in the right of way doesn't mean that is their property.
They also have a side lot here. And they have a pull-off here. So we're not pushing the road toward their house. We're not changing the edge of road. I guess, the sidewalk is going in the end of the driveway.
Right. I don't think we can resolve that tonight.
I think we should just push ahead with it.
Absolutely.
Yeah.
I guess, yeah. So just, it's easy to look at this picture and think about it. Where the grassed area is here. This is where the sidewalk would be.
Yep.
And you don't think that there's going to be any fill behind it toward the house?
No. Everything is within the right of way, within the highway line. There is a very, very slight cut actually in front of this house.
Right. You were showing some cut and fill there, but it was pretty small. It was pretty small.
It's because just because the land is higher up on this side of the road than it is on the north side of the road.
Okay.
Anything else?
Oh, sure.
That was a great presentation. Thank you.
Thank you.
Yeah, and I think just also, Jonathan, before we, when we get ready to do the federal local bridge applications, we're gonna have to do, take this to the council and show them, what this committee has come up with and where we are. Because they'll ultimately have to authorize us to submit for that.
Yep. So yeah, a lot of our plans that we've shown in these meetings are, they have the aerial in the background, and we're trying to make it as user friendly as possible. I know it still looks like a lot of engineering gobbledygook, but we'll put together our formal roadway plan and
some cost
move
estimates.
ahead with that and the cost estimate.
Yep.
So you can take those next steps.
Just in the interest of transparency, is there any effort to make sure that Groton Long Point and Mumford Cove know how we're proceeding here? The summer is coming, and so the fair number of Groton Long Point folks are going to be in town. We don't need to hear about surprises.
At some point we do have to have a public informational session. Is that typically at the 30% stage, John?
Yeah, and
No.
we have the website, which Greg, I'm sorry, has been underutilized, but I think the thing to do would be to get our plans up there. And that's another tool for getting some feedback and just for getting the information out.
Websites from this old FUD, websites are a necessary but not sufficient condition for communication.
And earlier on, Frank, I'm sure you were involved with the public listening sessions that we had in Groton, and we're certainly willing and able to come back and do that in person.
Right. I know it's a bit of work, but sometimes it's better to do it earlier than later.
I agree.
Thank you.
Okay. Thanks, Greg, if we're
Okay.
good.
Anybody else have any other questions, comments?
No, so we're meeting in July, you think?
I think so. Yeah, you said you'll have cost estimates
Push
and
ahead
stuff?
with the cost estimate, yes, and with
Okay.
All right,
wrapping up our loose ends in the design here.
Okay.
Yeah.
Sounds good.
Yeah.
Give it a try.
yep, all right,
All right, thank you very much.
All right,
Thank
thanks,
you.
everybody.
Thank you.
all right.
Stay well, folks.
Good night.
Night.
All
Night.
right.
Night night.